So this paper is about, it's a work I've been done about the evaluation of at least the last Brazilian censuses, evaluation of coverage and quality, especially through demographic analysis. So just as an introduction here, just say that censuses are the main activity undertaken by an official institute of statistics and the most important source of demographic information in developing countries, especially in this case in Brazil, especially for small geographic areas, for municipalities. Sometimes it's the only source of a lot of information. And it's known that there are some coverage and quality problems in censuses that are inherent to activities of this magnitude, and then it's essential to evaluate and measure those problems in trying to find a way to improve those collected information. So going directly to the main point, this paper intends to present an indirect evaluation of the last two Brazilian censuses. So we also had their direct evaluation, which is the post-enumeration survey, but here we are just trying to evaluate through the demographic analysis, which is the indirect technique. And there are many purposes of evaluation. I discussed a little bit in the paper, but here the main purpose for this paper here is adjusting the census results, basically to adjust the base population for the projections and estimates. So basically we are going to adjust the census population for the 2000, and then that's the base population for our projections. So our population projections. So we can measure some coverage errors, especially in certain ages that we know the omission is higher, and for example for children. And we can also try to estimate some kind of content errors like age exaggeration among elderly populations. So here just want to say that we need to estimate some expected measures and then compare to the actual observed measures. So here just to say that the sex ratio in certain age and time does not depend on the fertility, it just depends on the sex ratio at birth and the probability, the survival rates of males and females. So just to say that, and now here we are considering that we are considering that Brazil is a closed population. We can discuss a little bit more, but we've been discussing this there. We think that the international migration there it's too low, that we can consider Brazilian population as a closed population. So, and here we compare for 2000 the sex ratio, expected sex ratio here based only in the historical mortality information, which is here in blue, and the actual observed sex ratio here. So for example 2000 it's here in the yellow. So we can see that our expected sex ratio is higher than the actually observed sex ratio. And one possible explanation is that males at these ages here are more likely to be undercoverage in censuses. It's one of those explanations of this huge difference here. So it will be useful for our purpose of the method here. Another thing that we compare is the census survival ratios. When we divide the population, in this case it's the 2000 and 1990 censuses, we divide the population, for example here from age 10 to 14, we divide by the population 10 years earlier between 0 to 4, and then we have our survival ratios here. So he's saying that we had in 2000 more children with 10 to 14 than children with 0 to 4 years, 10 years earlier. So it's showing probably that children in this first census was underestimated. There was a under coverage by the census. And here is the opposite. So it's this ratio, 25, 29 divided by 15, 19. It's lower than the ratio we expected. So we could go and compare those observed and expected sex ratios and census survival ratios to see where could be our problems in coverage and basically coverage of those different age groups. So we can see here the last 10 years we have basically a similar pattern of undercoverage, showing that it could be undercoverage here and here those ages 25 to 29. So based on this, the analysis of this, every single year, every single age group, we do this exercise called demographic reconciliation. This is how, for instance, CELADE, the Latin American Center for Demography, they try to adjust the census results to use as their starting point of their population projections. So we are doing basically the same thing. This method consists in evaluating the coherence between two different censuses, actually historical censuses, and the demographic trends during this period. So it's basically trying to find a coherence between this information that we don't see here actually. If we, for example, if we just use the observed population in 2000, we are going to underestimate all these age groups in our population projection, so we have to adjust this base population. So what we did was project the population from 1990 and back project the population for 2010, and then we have 3 different estimations for 2000. So we have a 1990 projected for 2000, 2010 back projected, and then basically we decide for every age group which group we think that's a more reliable estimation. And we also have for males and females. We can estimate population for males population multiplying the females times the sex ratio, the inverse of the sex ratio. So that's basically what we did, and then we have a matrix with 6 different values for each age group, and then we discussed, based on their previous analysis, we discussed what will be the most reliable age groups to use. So here are some, and then we discussed with a group of specialists there from IBGE, which is the Brazilian Institute of Geography and Statistics, which is the institution responsible for making this population projections. So basically, I give more details in the paper, but here, basically, our decisions were not using the information observed in the census from 0 to 4 and 5 to 9. So basically, we used the information from 2010 of the children with age 10 to 14 and 15 to 19, and also the projections, the number of children projected by the fertility rates during the 1990s. From 10 to 49 years old, due to higher male population under reporting, basically based on that sex ratio graph, we were more likely to use the information for women, and then we could estimate population for men based on the sex ratio. And for age groups older than 50 years old, we tended to use the groups for this census from 1990, because it refers to a younger age groups, and then we understand that, for example, a group from 50 to 55 in 1990, the information declared for them, it's more reliable than 70 to 75, 20 years later. So those were basically our decisions, and then we have this final graph. The black line here is the observed in the census, and then the red line is the adjusted population. So we can see that we adjusted here for the 0 to 5 and in 0 to 4 and 5 to 9, and then here for males, a little bit here for females, and then here we don't see here, but we tend to normally the census, we have more people here in the census than people there we estimate, because there's the effect of age exaggeration among elderly population here. So our main conclusion is that it leads to a more reliable estimate than the census itself, because as I told you, if we use this population without adjustment, we are going to, in our projection, this difference here, this number of children here we are going to keep replying this difference here. So we think it's more reliable to use an adjusted population. An important challenge is the coverage estimation for small areas, because we can do this thing for the whole country, but it's difficult to redistribute these differences for small areas, for example, for states that we have to redistribute. What we did, it was use basically this general idea, put in the model the difference here by age and the general under coverage measure for the states given by the post-evaluation survey for this year. So, but it's a challenge, because we cannot use this technique for the states, for example, because we don't have enough information about migration. So we had to include another variable here for the country. We are assuming that it's a closed population. And another thing is that these methods, it depends a lot on the quality of our information, of our mortality and fertility information, and also migration. So I think one way to improve the estimations is improving the measures of each of the components. So that's the general idea of this paper.
Great, so we have time for I think, a question or two.
I wonder if you've heard of the domain shorter method, or whether I haven't seen any reference to it for a long time, but it was developed. If you have a family of model life tables, or if you have some way of, say a one parameter way of varying the level of mortality, and you have two censuses with age distributions, and you can assume that it's closed, or you've already adjusted for migration on the side, and that you assume the degree of under enumeration overall is the same in both periods, where you've adjusted beforehand. Then you can solve analytically for the level of mortality and the degree of adjustment up or down at each age that makes the whole thing balance under the assumptions.
Okay.
And that's the domain shorter method. And then I did some work on this also with David Lamb when he was here, and we have a paper in Pop Studies. So whether it's still relevant in this day of rather better data and more reliable vital registration systems and so on, I'm not sure, but it's worth looking at. It may just have been forgotten.
Yeah, no, I think it would be, I didn't know about this method. It would be useful because, yeah, we can adjust both things. Here we take for granted our demographic estimation, and then we try to adjust, try to only adjust the coverage, but we can also, if we put those things together, we can balance
Yeah.
and re-estimate our mortality.
You might just do it and compare it to
Uh-huh.
what the results you found this way.
Yeah, one thing is that this model is interesting because you can change and you can, if we see that there is a higher difference here, we can think that's not reliable our fertility information, and we can re-estimate the fertility, and so we can
Yeah.
play with different changes in trying to find a more
Okay, let's get one
coverage.
more quick question. Simulating a real PA session.
How important is international migration for Brazil?
Yeah, I think it's, well, the Brazil in 2010, it has around 200 million, it was the population, and the immigrants for Brazil, it was 0.01% of the population.
So that makes these methods much more promising than they would be in the country.
Yeah, that's,
Yeah.
yeah, I think that's one of the main points here, because we can actually you can assume that even if it's not a close population, we can it's too small, and you can assume that the number of immigrants and the people that go into the country and then the flow outside the country, they kind of balance. And then we also, when we did that sex ratio estimate, we compare males and females. The international migration is very similar for males and females, so it balanced.
Okay, we have good incentives because you could take away from your own time later. So let's stop here. Write down your questions if you have your hands up so that Gabriel gets all the feedback that we want to give him. And go to Robert now, is that right? Oh, you're not gonna take away, okay.
Yeah,
That's
I'll
okay,
go to the other
but just make sure that you leave Robert enough time.
Okay.
All time.
Yeah.